Hello, everybody. Today we're going to cover convolutional neural networks. Now, I thought that before we jump into Python, maybe we need to learn a bit about how convolutional neural network works, so that we have a better knowledge of this field, and therefore it's easier to implement in my Python. So let's start. Okay, so in this series of slides, I'm going to introduce to you three things. One is, what is a neural network and deep learning? Second is, what is convolutional neural network? And finally, I will talk about the project that I did called Alzheimer's diagnosis. So first, what is a neural network and deep learning? Okay, so in I believe it was the 70s, psychiatrists, neurosurgeons, they understood that the brain involved neurons. And there was this goal to replicate the brain using individual neurons, how neurons behaved. So that's how neural network began. It was highly influenced by neuroscience. And what happened in the computer science is that their similarity is based on the neuron. So the neuron looks like this, each one. You have a bias here, which is a value that's it's a static number. Okay, then you have other inputs here, and these inputs are weighted. So x1 multiplied by w1, by the weight w1, and x2 multiplied by the weight w2. In this circle right here, all these values are added together, and then finally a result is spit out as a y. So that is a neuron by itself. When we do deep learning, what happens is that we have many layers. Deep learning means like deep, as in there's many layers involved of neurons, okay? And it has been learned that the deeper the neural network, sure, it is harder to train, but more accurate your results are. So how do you train a deep learning neuron? Okay, there's three criteria. First, you need to have what's called an optimizer. And basically what this means is that the change between the predicted and the target has to reach a minimum error, minimum problem. There's also a loss function, and the loss function is what calculates the difference between the predicted value and the target value. And then we have a function which determines how accurate the predictions are. So based on these three items, we train our deep learning model. So now let's talk about convolutional neural networks. Okay, convolutional neural networks is a type of deep learning that's specific for imaging. That's where it was born from and where it's most successful in. And basically, it's divided as how we see in this diagram here. We have an input, then we have an area called feature learning, and then classification. So feature learning consists of many layers that combine a convolution and pooling. So it's called feature learning because what it means is that, let's say you have a picture of a face, right? We can say horizontal features, so all the horizontal lines. Oval features, all the circle lines, right? So we're learning the features of the image, the components of the image, and that's why it's called feature learning. Convolution is a filter that is able to pass over the input and then extract the necessary details. For example, straight lines, horizontal lines, so on. What happens to pooling is that we have a massive amount of data, so we need to collapse it, to shrink it. So pooling takes within one area and takes the maximum value and shrinks it. So I'll explain to you this a bit later on. Okay. So after the feature learning, we have the classification area. And what the classification is that it takes all the results from feature learning, the final results of feature learning, and then what it does is that it does a classification. Is it a dog? Is it a cat? Is it a car? So that's convolutional neural networks in a nutshell. Okay, so this is just a better understanding. So I said convolutional filters, they extract features. So here we have a very, this image is a very popular image in, it has this historical presence in engineering, electrical engineering. So anyways, we have the photograph here, and here we have extracted all the features, and in this case the features is the outlines. So that's what convolution does. And here we have max pooling. So here what we do is 2 by 2. So it's a 2 by 2 matrix, and we pick out the maximum. So let's say this corner right here. The maximum is 20 out of 12, 28, and 12. So we put 12 here, 20 here. In this section, it's 30, so we put 30 there. In this section is 1, 1, 12, and the other section is 37. So that's max pooling. So this is just more examples to make you understand further. So here again, we're learning the features, right? We start with the lines, then we go through noses and eyes, and then faces. So this is how the convolutional network works. And then the final layer, which I told you is the classification layer, usually it's a softmax function, and it ranges from 0 to 1. So for example, if we have 3 items, right, we can say, okay, we want to check if this dog is a dog, okay? So we see here that the dog has 0.46 probability of being correct, whereas being a cat is 34, being a fish is 20. So we picked the highest one. So that's the final layer. Okay, so now some fun stuff regarding my topic that I did for my master's project. So I was very fortunate to have my paper published at an IEEE conference. It was such an amazing experience. I want to repeat the experience. I love going to conferences. I love the opportunity to write in a journal. So this was my project. Okay, so basically what I did is I used convolutional neural networks to diagnose Alzheimer's. So what is Alzheimer's? Alzheimer's is a disease of the brain that affects people generally when they are senior or older. Okay, and what happens is that their hippocampus, which is the area of the brain that takes care of memory, starts disappearing. So here we see 2 images. On the left, it's a normal person, and on the right, it's somebody with Alzheimer's. And we can clearly see at the center here that the one with Alzheimer's has a very big hole here, which means huge loss of hippocampus. So my convolutional neural network is going to recognize this and spit out if the image is Alzheimer's or not. Okay, so I did something very interesting in this project, and that was, instead of creating a neural network by scratch, I borrowed one that already won a competition. Okay, yearly there's this competition called ImageNet, and it's a competition where there are millions of images, and you have to be able to classify them. Is it a cat? Is it a dog? And so on. So this has been a competition that's been going on for, I think, a decade so far, very long time. When I did my project, what I did is that I learned about Inception V4 and also VGG16. Okay, and Inception V4 was most successful in ImageNet. VGG was also successful, but at the earlier time period. So let's jump to the next slide. So I just want to impress upon you how complicated these neural networks are. This is a very rough sketch, a high-level view of Inception V4, and this is huge. When I went to the conference, people in my area, they were talking about how they use neural networks to do their classifications, to do their diagnosis. And the people in the audience were asking them always the simple question: how do you know how to build a neural network? How do you know you need to have 5 neurons? How do you know you have to have 10 layers? And the people didn't have a response. They all said, oh, until my graphics card couldn't handle anymore, or until the accuracy was high enough. And that's not a very good answer. In fact, that answer is more an art than a science. And in fact, actually, doing classification deep learning is indeed more an art than a science at this period in time. Because there is no set rules. If you have 5 features, you need to have 100 neurons. If you have 4 features, you need to have 3 neurons. There's no set rules. Everything is based on how the researcher builds it based on his experience. So it's still an art. So when I introduced my topic, it was very interesting because I didn't program a neuron. In fact, I reprogrammed something that happened before. So basically what I did is called transfer learning, which means, here I have a definition. Transfer learning is a machine learning method where a model developed for a task is reused as the starting point for a model on a second task. So basically here we have imagine this is my Inception V4 that I copied. Okay, so I took the whole model, the whole trained model, and I took out the last classification bit and reprogrammed that. So what I did is that I was using all the training, all the architecture that the model did, the Inception V4 did, and I just classified the very end. And it turns out actually that using what's called transfer learning really does improve your accuracy. So I did VG16 from scratch and I got an accuracy of 74%. Then I did VG16 with transfer learning and I got an accuracy of 92. And Inception V4 I got an accuracy of 96. So and that was an amazing result because I didn't have to program a new deep learning algorithm. I just used something that was already there, and the accuracy was very high. So as a testament to how good this topic is, I'm proud to state that my article has been cited 67 times. So that is convolutional neural networks in a nutshell. I will now go into Jupyter and we're going to jump into some code. So let's take a look.